Welcome back to our lesson practice review. Today we're doing chapter 2, lesson 9. Our summary here that I'm going to kind of make even smaller is we're dealing with lots of i's and I squareds and I to the power of 4, 5, 6, 7, 8, 9. So in this case here, the key to this is understanding that I squared is equal to -1. And so I'm going to be kind of separating things out so that we see that I squared becomes -1, and that is going to be used to help us with this. And so, for example, if we see something that is a odd power, we're going to separate it so that it's I to the power 4 times I, which we know is I to the power 5, but I to the power 4 is I squared times I squared, and I squared is -1. -1 times -1 is just 1. And so whenever we have an even power, we end up getting rid of the i's. The odd power then leaves us with an I left over. And so when we are simplifying, I to the power of 5, that's the way we're going to do it. All right, for each expression, write an equivalent expression in the format of a plus bi. So in this one here, we're really just combining like terms. Any i's here, plus 4i is 8i, minus 2i is 6i, and then 3 plus 6 is 9. So my final answer here after I've combined like terms is just 9 plus 6i. For the next one here, I'm going to go ahead and distribute this I in to get -3i plus 7i plus 5i squared. The key part here is that I squared is just -1, so I'm going to combine these two to get positive 4i, because -3i plus 7i plus 5 times -1, which becomes 4i minus 5. And it asks us specifically to make sure that it's in this correct form. So I'm going to say it's -5 volts plus 4i. And for number 3 here, we got this negative that I'm going to distribute. So I get 5 plus 2i minus 3i minus 8. I'll combine like terms here. 5 minus 8 is -3. And then 2i minus 3i is -1i, which I'm just going to leave as -i. So it's just kind of distributing and combining like terms on those ones. For number 4, match the equivalent expressions. So first one here, I'm going to go ahead and simplify by distributing these to get 6 plus 2i minus 3 minus 6i. 6 minus 3 is 3. 2i minus 6i is -4i. So that would be A right there. I'm going to erase this so I get some more space. Next up, distribute to get 2i plus 3i squared plus 2i. This I squared becomes -1. So if I do 2i plus 2i, I get 4i plus 3i squared. And the I squared becomes -1, which I'm switching this around here to become -3 in the front plus a positive 4i, which tells me that the first one is B. Should probably do this with a little bit more space to the right here, but we're going to jam it in. Probably what you're doing on your notebook anyways, so I figure, when in Rome. 6i minus 3 plus 6 minus 3i after distributing. 6i and -3i become positive 3i. -3 and positive 6 becomes positive 3. So 3 plus 3i becomes C. And yes, we could use process of elimination to say that our final answer here is D, but just because if you're watching these videos, you probably want the practice anyways, I'm going to go ahead and show how that works. 4i plus I minus 6 minus 3i plus 3. I'm going to do all my constants first, so -6 and 3 is -3. And then 4i plus I is 5i, minus 3i is positive 2i, which gives me negative 3 plus 2i. All right, next up, number 5. Which of these complex numbers is equivalent to what we started with here? And again, they're kind of, I don't know, I feel like they're giving you multiple choice and these like select all or matching questions really just to, I don't know, try and change up the way that these look. But we're really kind of doing the same thing each time. Minus 13i to the power of 5. And so when I do this, I want to simplify all the things that are greater than just I. So this becomes 24 times negative 1, and 8i stays the same. And then I to the power of 5, so 13. Remember, I to the power of 5 is equal to I to the power of 4 times I, which is equal to I squared times I, which is equal to negative 1 times negative 1 times I, which is equal to 1 times I, which is equal to just I. So in this one here, I to the power of 5 just simplifies to positive I. Now, I'll rewrite this one more time just to multiply 24 times negative 1. And then I'm going to combine like terms here with my two values of I to get negative 24. And then 8 minus 13 is negative 5i. And when we look over here, we got our answer of B. All right, number 6. Bao claims that 8 minus I to the power of 7 and 8 plus I to the power of 9 are equivalent. Is he correct? Well, I would personally say yes. The reason that I would do that is because if I take this second one here, 8 plus I to the power of 9, that's the same thing as 8 plus I to the power of 9 times, plus I to the power of 7 plus I squared, because that gives us, it's breaking down I to the power of 9 here. And I know that I squared is just equal to negative 1. So plus I to the power of 7 times negative 1, which ends up becoming 8 minus I to the power of 7, which is what we said that they are equivalent to. Number 7, using the digits 0 to 9 only once, fill in the boxes to create the smallest real number that you can. So my thought process on this one is that when we're dealing with a small real number, we want either something really close to 0, or if we can get it, a negative number, because that makes it smaller. And when we're dealing with i's, that's the important thing, is that whenever we have an even number of I squareds, or i's, I guess, then we have a negative number. And so when we're plugging this in, these are going to be positive numbers. So I want the smallest possible positive numbers, like 0 and 1. And then these are going to be, we want them to be even, because if they're even, then that would make this second term a negative number. And so it also has to be even because it's got to be real. And so in this case here, some even numbers to choose are 2 and 4. And then with this number here, we actually want these numbers to be really big, because we want to add negative numbers so that we get smaller and smaller values. So our two largest numbers that we can choose from 0 to 9 are 9 and 8. And so that would end up giving us our smallest real number. Again, it would give us a negative answer, which is good, which is the smallest real number we get. Problem 8 through 10, determine each product. So in this one here, distributing to get negative 3x squared minus 12. That's pretty straightforward. Number 9, I'm going to use my trusty box here, 2x minus 3, negative 5x plus 1. When I multiply, I get negative 10x squared plus 15x, and then plus 2x minus 3. Combine like terms to get 10x squared, negative 10x squared plus 17x minus 3. And last one, again, I'm going to use my box because 5 minus 6x squared is the same thing as 5 minus 6x times 5 minus 6x. 25, negative 30x, also negative 30x. I could also use my identity to help me with this, but I didn't do it. And then I combine like terms to get 36x squared minus 60x plus 25. And that finishes up our Chapter 2, Lesson 9 practice. Next up will be Lesson 10. We only got a couple more before we wrap up Chapter 2 here, so keep up the good work, and I'll see you in the next video.